Is Surya Prakash, Professor in Mechanical Engineering, Mlritm. Today, my subject is Engineering Mechanics, and topic is free body diagram. Now, in this engineering mechanics, okay, outcomes, again, course objectives. After that one, introduction to engineering mechanics. The first unit is introduction to engineering mechanics. What is meant by engineering mechanics? Engineering mechanics is the branch of the science which deals with the effect of the forces acting on a body. Effect of the forces acting on a body when the body is in rest or in motion. Suppose now this is a body. Now this is a body. The number of forces are acting on this one. There are number of forces are acting on. What is the behavior? What is the effect of the body? That is called the engineering mechanics. I'll repeat. Engineering mechanics is the branch of the science deals with the effect of the forces acting on a body when the body is in rest or in motion. That is called the engineering mechanics. Now in this engineering mechanics, there are some first unit, there are some topics are there, important topics. That is a system of the forces. What you mean by system of the forces? The number of forces simultaneously acting on a body, that is called the system of the force. You take example of this one. A vehicle, the vehicle is in rest position, there are some forces are acting. Frictional force will act. Okay, that forces will calculate. Suppose that when the body is moving, when the car is moving on the road, the wind forces, the frictional forces, these are all acting. That we will calculate, okay, in this system of the forces. Now the another important in the first unit, that is a movement of the force. What is meant by movement of the force? Rotational effect produced by a force is called the movement of the force. Now this is a body. It is a body. When you apply some force, this body will rotate. This object will rotate. So now that is called the movement of the force. The rotational effect produced by a force is called movement of the force. Next, that another one is a resultant of the force system. Resultant of the force system. Okay, here we have the given force. We have to split or break into two mutual component. That is called the okay resultant of the forces. The given force we have to split perpendicular to each other. The next last one is a free body diagram. Free body diagram means the given diagram we have to sketch and showing the all the active forces, inactive forces, and remove the supports and consider the geometrical angles and geometrical dimensions is called the free body diagram. Now the second unit is friction. What do you mean by friction? When the body moves over the another body, when the body moves on the another body, the tangential force is up, developed in between the two surfaces. Okay, now one body is here, now it is on the another body. Okay, so now what will happen when you apply the some force? When you apply the some force, okay, the frictional force will develop between the body. How it is? Opposite to the motion. The frictional force is always opposite to the okay motion. Next, now in this friction there are okay static friction and dynamic friction. Static friction means when the body is in the rest position, that is called the static friction. When the body in the slides on the surface, that is called the okay dynamic friction. Now again another one is the ladder friction. Ladder friction means here we have to find out the friction between the surface and the ladder. Now this is a surface. Now this is a surface. Now it is a ladder. Now it is a ladder. Now we have to find out the okay the friction between the ladder and the surface. So now this is about okay friction. Now second unit. Now come to the third unit. Come to the third unit. The third unit is itself is a centroid and a center of gravity. The third unit is centroid and center of gravity. What do you mean by centroid and center of gravity? Okay, it is a point where total area of the mass assumed to be concentrated. Now here one body is here. Now here we have to find out the what is the center of this one. Suppose the body is like this. So now what is the center? That we can find with the help of the centroid. Centroid means a point where the whole area of the center is concentrated one particular point, that is called the centroid. And the center of the gravity, centroid and center of gravity is a definition is same, but only thing is the centroid is a two-dimensional, whereas the center of gravity is the three-dimensional. A point assumed to be concentrated on the weight of the body. Okay, now after that one we will go to fourth unit. Okay, movement of the inertia. What is meant by movement of inertia? The changes in the rotational of the body to resist the change of the body. Now in this one area of the movement of inertia and mass movement of the inertia, we have to find out the what is the area of the mass movement of inertia, what is the mass movement of the inertia. Next one is a kinetic of rigid body, kinetics of the rigid body. So now today my topic is a free body diagram. So now what is meant by free body diagram? What is meant by free body diagram? Free body diagram, what is the purpose of the free body diagram? Here to calculate the unknown forces. To calculate the unknown forces. Now this is a body. There are number of forces are acting on this one. Suppose you know that this is the 10 Newton, this is 12 Newton. Now this is the unknown force. This force we can find in this free body diagram. Next purpose is simplify the complex forces. Number of forces are acting, that we can simplify the forces. Next one is to understand the direction and effort of the forces. Okay, now what do you mean by free body diagram? Free body diagram means sketch the diagram and showing the all active and reactive forces and remove the all the supports and consider the geometrical angles and directions is called the free body diagram. Now I will show the free body diagram. What is meant by free body diagram? Now this is a given body. Now this is a given body. Okay, so now for this one I want to draw the free body diagram. What is the free body diagram? Telling that sketch the body. I draw the diagram, and after that one show the active and reactive forces. According to the Newton's law, every body is same action and reaction. Okay, now one action is total weight, another one is according to Newton's law, that is a reaction. So now the every body, next one after that one again we have to remove the support. We have to remove the support. I remove the support. Okay, again we can show the geometrical angles and distance. Suppose is there any angles or any dimensions we can show. That is called the free body diagram. That is called free body diagram. Next one is the example is, we will see the one example. What is the example? A ball resting on a floor. A ball resting on a floor. Now this is a ball. It is resting on a floor. Now it is the center of the ball. Now here we have to draw the free body diagram. What is the free body diagram showing? I will draw the free body diagram. It is already given, FBD, free body diagram. Now draw a circle. Okay, draw the diagram or sketch the diagram. Show the active force. It is a weight. Okay, self weight. Again the reaction. It is a RA. Now this is called the drawing of the free body diagram of this given example. So now as per as the third law, every action there is equal and opposite reaction. Every body there is equal and opposite reaction. Now after that one, see that Another second example. What is the example? A sphere of the weight W freely supported by string connecting the ceiling. Now this is a given, okay, okay, body. Now it is supported the, okay, string. It is the supported a spring. Okay, it is on the ceiling. For this one, I have to draw the free body diagram. I have to draw a free body diagram. Because of the freely hanging, there is a self weight is there. There is self weight. Again, now it is hanging to the ceiling means there is a tension in the string. There is a tension in the string. Now this is called the, okay, free body diagram. Okay, the given figure we have to draw a free body diagram so that we can find the unknown forces, unknown tension in the string. Next one is the third example. A spear suspended with the string resting against a wall, vertical wall. Now this is a spear. This is a spear. Now it is a wall. This is a wall. Now it is suspended a string. It is a suspended a spring. For this one, we have to draw a free body diagram. What is the free body saying? That draw the diagram, same diagram. After that one, okay, remove the, okay, supports. I remove the support. Again, showing the active and reactive force. Because of the suspended, there is self weight. Next one, here the string is suspended means the tension in the string. The tension, that is a TBC, tension in the string. Next one, it is supported by a wall. This is supported by a wall. So that okay, this is called the reaction at A. This is reaction at A. Now it is a drawing of a free body diagram of a given suspended sphere vertical wall. Next we will see the example of third one. This is third one. A cylinder W weight supported on a smooth horizontal surface and pulled by the support. Now this is a given sphere where it is on the surface. It is on the surface. Okay, it is supported by a, okay, force. It is supported. It is a one force is acting on this one. The string, okay, it is suspended like this. For this one, we have to draw a free body diagram. We have to draw free body diagram. Now draw the same diagram. Okay, show the diagram. Again, show the active and reactive force. W is the active and RB is the reactive. And the force, same force here we have to take. Because of the force, there is a tension. Because of this P, there is a tension is developed in this one. Tension is developed in this one. That is, now that is the tension is the TAC. TAC. Now this is the free body diagram of a cylinder supported on the smooth horizontal plane. Now after that one, Lami's theorem. Lami's theorem. Okay, Lami's theorem states that the three forces are acting on a point. This is a point. There are three forces are acting on a point. Now this is a P, this is Q, this is R. P, Q, R is the three forces are acting on a point. It is in the equilibrium condition. What is meant by equilibrium condition? The number of forces are acting on a point is equal to 0. That means P is equal to Q, Q is equal to R, so that it is in the equilibrium position. So now the three forces are acting on a point in equilibrium position. Each force is sine angle of between the two other forces. Each force is, okay, sine of the angle between the other two forces. So now this is a theta 1, this is a theta 2, this is a theta 3. Now according to the Lami's theorem, okay, each force is proportional to the sine of angle. Each force, now the P is a force, sine theta 1, opposite one. Next one is a q sine theta 2. Now the r sine theta 3. This one, according to the Lamis theorem, okay, according to the Lamis theorem, p by sine theta 1, q by sine theta 2, r by sine theta 3. So now it is called the Lamis theorem. What is by Lamis theorem? We can find out the unknown forces. Unknown forces are acting on a body is the Lamis theorem. Next we will see one problem in this one. An electrical light fixture weighing 150 Newton. Okay, the electrical fixture at point C. At point C, one electrical fixture, or let us take the bulb. It is a bulb. What is the weight of the bulb? 150 Newton. At C, two wires are the AC and BC are inclined. AC, this is a A. Now this is a B. This is a B. That okay. Now what is the angle? The AC is what is the angle? 60 degrees. Again the BC is 45 degrees. But now we have to find out what is the tension in the AC and BC. We have to find out the tension in the AC and BC because it is an unknown one. We know the tension in the body, that is a C that we know, but we don't know what is the tension in the B and the tension in the A. Now after that one we have to draw a free body diagram. We have to draw a free body diagram. See this one, how I am writing the free body diagram. Now this is a C. Okay, now it is a tension TAC because the AC. Now the another one is a TBC. Another one is a T. Or another one is a only 150 Newton. What is the angle? It is a 60 degrees. It is a 45 degrees. 45 degrees. But according to our formula, what is the formula of the Lamis theorem? P by sine theta 1, Q by sine theta 2, R by sine theta 3. So now, okay, so now this is equal to P, this is equal to Q, this is equal to R. So now the P by sine theta means, now what is this angle? What is this angle? Opposite angle. Opposite angle is, it is a 45, this is a 30. So now it is a 75 degrees. Now what is this angle? This angle is 45. Again this is a 90. 90 plus 45, 135. Now what is this angle? Okay, 60 plus 90. So this is a 150. So now go to the second slide. Now this one, free body diagram. So now the 60, okay, again 45 again. So now for this one we have to solve the problem. So now what is the Lamis theorem? P by sine theta 1, Q by sine theta 2, R by sine theta 3. Here this is called the P. This is Q. This is R. So now the P by sine theta. What is the sine theta? Opposite one, 75 degrees. 75 degrees. Now Q by opposite one, how much? Sine 135 degrees. Next one, R by what is this one? How much? R by 150 degrees. P means TAC sine 75 degrees. Q by sine 1 TAC. This is 150. Okay, TAC. Okay, 135. Now this is okay TBC divided by sine 50 degrees. Sine 50 degrees. Now the equating the two, this two, so that I will get the TAC. So now how I can write a TAC is equal to 150 into sine 135 divided by sine 75. So now after this one, so you will get how much? 109.81. 109.81. Now I need another one, another TBC. Now after that one, equating two things on. What is that one? Okay. So now, okay, TBC equal to TBC is equal to 150 by sine 75 into, okay, sine 150, sine 150 degrees. So now the TBC equal to, okay, TBC equal to how much? 77.65. 77.65. So that here TAC is equal to how much? 109.81 Newton. Now the R TBC is equal to how much? 77.65 Newton. So now with the help of the free body diagram, we can find out the unknown forces. We know the only one force, but we can find out the another two forces. Now see this one here. It is already given in the second slide. Here it is given. Applying the Lami's theorem, P by sine theta 1, Q by sine theta 2, R by sine. So now this is a equation. From this equation, we can find out the TAC, again TBC. So the tension in the wire 109.81, the tension in the wire TBC 77.65. Okay, thank you very much.